Hey everybody, we were just comparing fractions and finding least common multiple in the last section that we did. So let's quick review how to compare fractions. How can you tell which fraction is bigger? Well, number one, simplifying helps a whole heck of a lot. And you can find equivalent fractions using least common denominators, either by simplifying or multiplying, okay, as long as you multiply the numerator and denominator by the same number. Number two, you can make the fractions into decimals and compare the place values, but that's really going to probably take the most time. And number three, probably the quickest way most often is to use cross products to compare the numerators. So let's try these out, and I'm going to probably solve these the quickest way. So if I'm using cross products here, I get 21 compared to 18. 21 is bigger than 18. Although I could find a common denominator and say 6/9 compared to 7/9, 7/9 is bigger. Okay, this guy, I could say 6/10 is bigger than or smaller than 7/10, or I could use cross products and say 35 compared to 30. 35 is bigger. Okay, this one, I'm going to use common denominators because I see a 4 and a 16, and I know 4 can go into 16. 4 times 4 is 16. 3 times 4 is 12. So what's bigger? And be careful with the negatives. Negative 12 or negative 13. Negative 12 is bigger because it's closer to 0, right? I'm going to simplify both of these because that always helps. 2 goes into both 3 and 7 times. 3 goes into both 3 and 7 times. They are equal to each other. Okay, they are both negative on this side. 2/8, so I'm going to simplify to 1/4. Now I'm going to use my cross products. 4 times 7 is 28. 1 times 32 is 32. They are both negative, so it's the one that's closer to 0 that's the bigger number. So negative 28 would be bigger. I don't even have to do work for this guy. What's bigger, a positive number or a negative number? A positive will always be bigger than a negative. All right, cross products, 56 compared to 60. 60 is bigger. All right, this guy, 35 compared to 32. They are both negative. It is the one that's closer to 0. Okay, simplify. 2 goes into both, 2/9. 3 goes into both, 2/9. They are equal to. Okay, a positive here is always bigger than a negative, so that is bigger. What's bigger, 4/7 or 2 and 4/7? Well, obviously, this one has 2 more, so that's going to be bigger. Kind of tricky. A negative divided by a negative, we know is a positive, and these two would equal each other at that point. Again, trying to trick you, a positive is always bigger than a negative. You don't need to do any work for that problem. This one I'm going to simplify. Negative 12 divided by 6 is negative 2. This guy, negative 3 divided by, or negative 9 divided by 3 is negative 3. Negative 2 is closer to 0. That is the bigger number. And I could have used cross products as well, or found common denominators. Okay, this one, do negatives. The opposite of negative is a positive. A positive is always going to be bigger than a negative. So hopefully you did good on that section. As a review, how do you find the least common multiple? Number one, you could go old school and list out all the multiples of each number and find the least multiple that they have in common. You could also use the slide method, which is probably the quickest, easiest method. All right, so do the slide, multiply along the letter L. L for least common multiple. Or 3, you could just use your common sense and ask yourself, all right, can the smaller number go into the larger number? And keep counting by the larger number if that doesn't work. And ask yourself every step of the way, does that smaller number go into the next one? Then do it again. Does the smaller number go into the next one? Okay, so you'll see what I mean here in a second. So we could do the slide. I'm going to do the slide for the first 3. 7 and 21. I'm going to do them down here. So 7 and 21. 7 goes into both 1 and 3 times. So now, because it's least common multiple, I multiply along the letter L. 7 times 1 times 3 is 21. But I could have just asked myself, well, 21. Can 7 go into 21? Yes, then 21 would be the least common multiple. 24 and 32. Do that right here. 24 and 32. I know they're both even, so 2 goes into both, 12 and 16 times. And I know 2 goes into both again, 6 and 8 times. And I know 2 goes into both one more time, 3 and 4. You could have did yours a little differently and used 4 or 8 to speed up the process. I just use 2 every time. So 2 times 2 is 4. 4 times 2 is 8. I know 8 times 3 is 24. And 24 times 4, well, I'll do that on the side. 24 times 4, that's going to be 96. So 96 would be the least common multiple. And if I ask myself, can 24 go into 32? The answer is no. If I doubled it, can 24 go into 64? No. If I tripled it, can 24 go into 96? The answer is yes. Okay, so that's how you would do that. All right, I'm going to do this the quick way. Can 15 go into 50? No. Double it. Can 15 go into 100? No. Can 15 go into 150 if I triple it? The answer is yes. So it would be 150. Okay, number 19, I told you last night to ignore the variables, so that's what we're going to do. 9 and 18, okay? If I just did the slide, if I didn't see it, right? If I did the slide, I could say 9 going to both 1 and 2 times. 9 times 1 times 2 is just 18. I say, oh, wow, that's easy, right? 28 and 42, we'll do that here. 28 and 42, well, 2 goes into both. 14 and 21 times, and 7 goes into both of those, 2 and 3. So remember, I can multiply in any order I want to. So I might say 3 times 2 is 6, 6 times 2 is 12, 12 times 7, that's a little easier because I know my 12s, right? 12 times 7 is 84, and 84 would be the numerical value there, and we're not going to deal with the variables tonight. I'm going to let you know, 9, 12, and 16. You can't do the slide here with 3 numbers. So this would be a long time if you did it. 9, 18, 27, 36. And you just kept listing out factors of 9. And then if you listed out the factors of 12, 12, 24, 36, 48, and so on. And then 16, 16, 32, 48. And if you had enough endurance to do that, I'm going to tell you that they do match up at 144 if you followed that process. So hats off to you if you got it. That's a tough and long problem. All right, the final 3 that you had for homework, because we didn't have to do 25, 26, and 27. A quality control inspector in an egg factory checks every 54th egg. 48th egg. Sorry, I didn't read that properly. They check every 48th egg for cracks and every 54th egg for weight. So when will they be checking the first egg for both of the things at the same time? So basically, this is the least common multiple problem. So 48 and 54, we're going to do the slide. 2 goes into both 24 and 27 times. 3 goes into both of those 8 and 9 times. And when you multiply along the letter L, 2 times 3 is 6, 6 times 8 is 48, and 48 times that 9, 2, 7, 36, 36 plus that 7 is 432. So on the 432nd egg, they would be checking it for the same thing. Okay, next one. A stock market or a stock sold for 3 and 5/8 one day and 3 1/2 the next. Did it go up or down? So basically, see how they both have 3 in common? We're really comparing the 5/8 to the 1/2. So pull it apart. 5/8 compared to 1/2. What's bigger? Well, this is more than half. This is less than half. You could prove it to yourself and do the diagonal trick, right? But 5/8 was bigger. So if it started on bigger and went smaller, it went down. Okay. And Marissa needs 2 2/3 ribbon. She has 2 3/4. Does she have enough? So basically, we're comparing 2/3 to 3/4. All right, because they both have the 2 in common. So what's bigger? 2/3. And I'm going to label this. This is how much she needs, and this is how much she has. So she has 9. Okay, she needs 8. So if she has 9 and needs 8, does she have enough? Yes, she does. Okay, and you can explain it that way. And you could also explain it with common denominators. 12 and 12. All right, you could say, well, 2/3 would be 8/12, right? Multiply both by, let's see, 3, 6, 9, 12. Multiply both by 4. Multiply both by 3 here. You get 9/12. And really, that's where the 8 and the 9 come from. So you could say, yes, she has enough. She actually has a 12th left over. So you could get even that specific, okay? So good job on the homework. Keep working hard. And remember, there's more than one way to solve a problem. And the smartest person knows multiple ways to solve the problems. And will use the right, tool for the toolbox to solve the problems, okay? We talk about that in class. All right? So good job, everybody. Keep on working hard.